In a particle physics lab in Switzerland in 1990, there was a computer with a handwritten warning taped to it, written in red ink. It said, "This machine is a server. Do not power it down." If anyone had actually switched it off, they wouldn't just have crashed a research project. They would have turned off the entire World Wide Web. Every web page, every browser, every website that existed anywhere on Earth at that moment. Because at the time, there was exactly one machine running all of it. That machine was a sleek black cube called a Next computer. It had been built by a company most people have completely forgotten, founded by a man everybody remembers for something else entirely, and the person who used it to invent the web wasn't trying to build a global communications revolution. He just wanted to stop losing track of which scientist had which piece of information. This is the story of Tim Berners-Lee, the quietest, least self-promoting inventor of one of the most important technologies in human history, and the strange detour through Steve Jobs' failed second company that made it all possible. Here's something worth getting straight before we go any further, because it trips up almost everyone, and it's central to understanding why this story matters. Tim Berners-Lee did not invent the internet. The internet, the actual physical and technical network of connected computers, the cables and protocols that let machines talk to each other across the planet, had already existed for 2 decades by the time our story begins. It grew out of American defense-funded research projects in the late 1960s and developed steadily through the 1970s and 80s. By 1989, scientists, universities, and governments around the world were already connected through it. Email existed. File transfers existed. The infrastructure was there. What didn't exist was an easy way to actually use any of it. If you wanted information in 1989 and that information happened to live on a different computer system than the one you were using, you were in trouble. You had to know which specific computer held it. You had to know how to log into that specific system, which might run completely different software than your own. You might need to learn an entirely different program just to read one document. There was no common language between different systems, no simple way to jump from one piece of information to a related piece sitting somewhere else. This was the exact problem facing the European Organization for Nuclear Research, CERN, the massive particle physics laboratory straddling the border between Switzerland and France. CERN wasn't one isolated building full of scientists. It was, and still is, a connection point for an enormous global community. Thousands of researchers from dozens of countries, most of whom only spent part of their time physically at the lab, constantly needing to share data, documentation, and findings with each other across incompatible computer systems scattered around the world. A British software engineer working at CERN named Tim Berners-Lee had grown increasingly frustrated by this exact problem. He'd watch colleagues struggle to find basic information, which guide explained a particular piece of equipment, who was working on what, where a specific data set actually lived, simply because it was trapped on the wrong machine, in the wrong format, accessible only if you already happened to know exactly where to look. Berners-Lee had a background that made him unusually suited to solving this. He'd studied physics at Oxford. Both of his parents had been early computer scientists themselves, part of the team that worked on one of the first commercially built computers. As a child, he'd been fascinated by trains and model railways and had built his own electronic gadgets to control them. The same instinct for taking a complicated system and finding the elegant control mechanism underneath it would define his entire career. By the late 1980s, working at CERN, Berners-Lee started sketching out an idea, not a brand new piece of technology. Almost everything he needed already existed in some form. Hypertext, the concept of clickable links connecting one piece of text to another, had been theorized for decades. The Internet's basic networking protocols already worked. What was missing was someone willing to combine them into a single unified system. As Berners-Lee himself put it years later, most of the pieces had already been designed. He just had to put them together. In March of 1989, he wrote it all down in a document with a deliberately unglamorous title, Information Management, a Proposal. You'd think a proposal that eventually became one of the most consequential documents in technological history might have been met with immediate enthusiasm. It wasn't. Berners-Lee handed his proposal to his manager at CERN, a man named Mike Sendall. Sendall read it, and on the cover of the document, in what would become one of the most famous understatements in tech history, he scrawled 3 words: vague but exciting. That's it. Not "this changes everything." Not "drop what you're doing," just a non-committal scribble that managed to be simultaneously dismissive and intrigued. The proposal wasn't rejected outright, but it wasn't accepted either. It just sort of sat there, unofficial, unfunded as a real project, for the better part of a year and a half. Berners-Lee revised and resubmitted the proposal in May of 1990. Around the same time, he found an ally, a Belgian systems engineer at CERN named Robert Caillot, who had independently been thinking about building a hypertext system of his own, and who became Berners-Lee's partner in trying to get the idea taken seriously. The two of them pitched the concept that September at a hypertext technology conference in Europe. The response was lukewarm at best. By Berners-Lee's own later account, they couldn't find a single vendor at the entire conference who genuinely understood what he was trying to build. Here's the detail that should genuinely surprise you. The World Wide Web, for its entire developmental life at CERN, was never an official, sanctioned, fully resourced CERN project. It existed almost as a side hustle, something Mike Sendall tolerated and quietly enabled rather than something the organization had formally committed to. Sendall managed to carve out actual working time for Berners-Lee to pursue it, starting in September 1990. But this wasn't a major institutional initiative with a budget and a roadmap. It was one engineer, one collaborator, and a manager willing to look the other way while real work happened on a project that, on paper, barely existed. This is worth sitting with because it cuts against almost every garage inventor myth you've probably absorbed from American tech history. There was no founder mortgaging a house. There was no venture capital pitch deck. There was a slightly bored, mildly supportive boss, an unofficial green light, and an engineer who decided to just start building the thing whether or not anyone above him had fully signed off. And to actually build it, Berners-Lee needed a computer capable of running everything he had in mind. CERN approved the purchase of a machine that, at the time, looked more like an art object than a piece of scientific equipment. A matte black, perfectly cubic computer, manufactured by a company called Next. If the name Next doesn't immediately mean anything to you, that's understandable, and also exactly the point of this chapter. In 1985, Steve Jobs, the same Steve Jobs already famous as co-founder of Apple, was forced out of the company he'd helped build in a power struggle with Apple's board and then CEO John Sculley. Rather than disappear, Jobs started a new computer company almost immediately. He called it Next. Next computers were beautiful, expensive, technically ambitious machines, built for the high end of the academic and scientific computing market. They were also, commercially, something close to a flop. High price tags and a limited software ecosystem meant Next computers never found anything like a mass audience. By most conventional measures of business success, Next was a disappointment. A footnote in the Steve Jobs story, the company that existed in the wilderness years before he eventually returned to Apple in the late 1990s, in a deal that, almost unbelievably, came about specifically because Apple acquired Next itself. But here's the thing about technically ambitious, commercially struggling computers built for academic and scientific institutions. They end up in academic and scientific institutions, including CERN. In September 1990, Berners-Lee got his hands on a Next machine and began building. And the Next computer turned out to be, by sheer historical coincidence, almost perfectly suited to the job. Its development environment let Berners-Lee build sophisticated software remarkably quickly compared to other systems of the era. Working largely alone in a matter of months rather than years, he wrote the 3 foundational technologies that the entire web still runs on today. The first was HTML, Hypertext Markup Language, the formatting system that defines what a web page actually looks like and how it links to other pages. The second was HTTP, Hypertext Transfer Protocol, the set of rules computers use to actually request and send web pages back and forth across a network. The third was the URL, the standardized address system that lets you point to one specific page out of, eventually, billions, with something as simple as a string of text you can type or click. He also wrote the first web browser, which he named, with characteristic plainness, World Wide Web, and the first web server software. Strikingly, that original browser wasn't just for reading pages. It let you edit them directly, turning the browser into both a reading tool and a writing tool, a feature that wouldn't become common again in mainstream browsers for years. By Christmas of 1990, working essentially solo on a computer most of the world considered an expensive commercial failure, Berners-Lee had built every fundamental piece of what we now simply call the web. And then he plugged it in and pointed it at the world. On December 20th, 1990, the first website in human history went live. Its content was about as unglamorous as the original proposal's title. It described the World Wide Web project itself, explaining what it was and how someone could go about using a browser, setting up their own web server, and building their own site. The address was info.cern.ch. If you want to, you can still visit a faithful restoration of that exact page today. A strange, almost spiritual experience, looking at the literal root of a system that now underpins nearly every part of modern life. For the first several months, almost nobody outside CERN had access to any of this. The original World Wide Web browser only ran on NeXT computers, and NeXT computers were rare, expensive, and confined mostly to a handful of research institutions. Recognizing this bottleneck, a student on a work placement at CERN named Nicola Pello was assigned to build something different, a much simpler line mode browser that could run on virtually any computer system of the era, even old terminal-style machines with none of the visual sophistication of the original. That decision, building a stripped-down, universally compatible version almost immediately rather than waiting for the broader market to catch up to NeXT hardware, turned out to be one of the quietly important choices in the web's early survival. It meant the web wasn't trapped inside a single commercially struggling hardware ecosystem. Anyone, on almost anything, could eventually get in. Meanwhile, the original NeXT machine itself had taken on an almost sacred status inside CERN. It wasn't just a web server. For a genuine stretch of early internet history, it was the web server, the singular physical machine hosting the entire World Wide Web's only content. Which brings us back to where this story started. The handwritten warning in red ink, taped directly to the machine, pleading with anyone who might wander by not to switch it off. There was no backup. There was no redundancy. There was a sticky note functioning as the only thing standing between the World Wide Web existing and the World Wide Web simply not existing anymore. In March 1991, the software became available more broadly to CERN's own internal computer users. Then, on August 6, 1991, Berners-Lee posted something to an internet news group called Alt.Hypertext, a short public summary of the project, inviting anyone interested to come help build it further. It's a strange thing to imagine. The public birth announcement of the World Wide Web wasn't a press conference or a product launch event. It was a forum post. People answered. Researchers at other institutions started writing their own browsers. A team in Finland built one called Urwies. A researcher named Pei Wei, working at the technical publisher O'Reilly, built one called Viola. By December 1991, thanks to two researchers named Paul Kuntz and Louise Addis, the first web server outside of Europe came online in the United States, fittingly at another particle physics laboratory, the Stanford Linear Accelerator Center in California. The web was no longer just a CERN curiosity. It was starting slowly to spread. Here's where this story takes its most important turn, and arguably the single most consequential decision in the entire saga, more important even than the original technical invention. By the early 1990s, the web had real competition. A protocol called Gopher, developed at the University of Minnesota, offered an alternative system for organizing and retrieving information across the internet. And for a while, plenty of smart people in the industry assumed Gopher, not the World Wide Web behind, would become the dominant way people interacted with online information. Then, in 1993, the University of Minnesota announced that Gopher would no longer be free. Organizations using it would need to pay licensing fees. Almost immediately afterward, CERN made the opposite decision about the web. On April 30th, 1993, CERN formally announced that the World Wide Web's underlying code would be released into the public domain, free for anyone, anywhere, to use, modify, and build upon forever, with no royalties and no licensing fees owed to anyone. Berners-Lee had advocated hard for exactly this outcome. He'd had every opportunity to angle for a patent, to keep central control of the technology, to position himself to extract a fee every single time someone, somewhere, loaded a web page. He chose not to. In his own words, explaining the decision later, creating something proprietary and keeping it under his personal control would have actively worked against the entire point of what he was trying to build. You can't simultaneously claim you're building a universal, open space for human information and also keep your hand firmly on the lever controlling who gets to use it. The timing could not have been more dramatic. Just 2 months after Gopher's licensing announcement scared off potential adopters, CERN's free, unrestricted alternative was sitting right there, ready to absorb all of that newly homeless interest. Developers who might have built on Gopher pivoted to the web instead. The free, open, patent-free nature of Berners-Lee's invention wasn't a minor footnote to the technical story. It may well be the single biggest reason the web won, instead of becoming a historical dead end like dozens of other promising but proprietary technologies from the same era. Early in 1993, a team at the University of Illinois' National Center for Supercomputing Applications released something called Mosaic, the first web browser built specifically to be friendly and visually appealing for ordinary, non technical people, not just researchers and engineers. Mosaic ran not just on Next machines or specialized academic systems, but on the kinds of personal computers and Macintoshes that regular households were starting to own. The arrival of a genuinely user friendly browser, landing right as the web had just become permanently free to build on, created the exact conditions for explosive mainstream growth. Within just a few years, the consequences of these two decisions, open code, friendly software, would reshape the entire global economy. Yahoo launched in 1994. Amazon and eBay both launched in 1995. Google followed in 1998. By the time Facebook arrived in 2004, more than 51 million websites already existed across the internet, built on a foundation given away for free by a quiet British engineer who never tried to extract a cent from any of it. Tim Berners-Lee never became a household name the way Steve Jobs or Bill Gates did, even though by some measures what he built mattered more than anything either of them created. He didn't found a company worth hundreds of billions of dollars. He didn't appear on magazine covers as a swaggering tech titan. In a 2016 poll of eminent scientists, academics, writers, and world leaders, ranking the cultural moments that most shaped the modern world, the invention of the World Wide Web took the #1 spot, ahead of nearly everything else humanity has produced in the last century. And the man behind it is, by most accounts, almost allergic to personal attention. He went on to found the World Wide Web Consortium in 1994, the organization that still helps guide the web's open technical standards today, ensuring no single company can ever fully capture or control it the way he refused to himself. He was knighted in 2004. He received the Turing Award, computing's highest honor, in 2017. But maybe the most fitting tribute to the man isn't an award at all. It's that strange sleek black Next computer, the commercial failure from Steve Jobs' wilderness years, sitting today as a preserved artifact, proof that the most important inventions in history don't always come from the companies built to dominate markets. Sometimes they come from the side projects nobody officially approved, built on the hardware nobody else wanted by the one person stubborn enough to give the whole thing away for free. If you found this one interesting, the early internet is full of stories just like this: inventions that almost didn't happen, decisions that could have gone the other way, and the strange coincidences that shape the world we're all living in right now.